So up till now, what do we use to persist data from one execution program to the next? Text files. Yeah, so normally if we declare a variable, that's all random access memory, and when we shut off the computer, the we lose the memory. We lose the data that we got from the user. So in order to persist the data, we've been using files. Another way we can persist files is by using a database. And there's some advantages that databases have over over files. One of those is that you can actually have multiple people accessing a database at the same time, and as long as they're not on the same element, it works okay. So the database system we're going to use is Sqlite3. It's a nice lightweight database that kind of runs as an application, so you don't have to have a server running with it. It just goes directly from your application to the database file. It is available as a library, and to use it, just like any other library, we use an import statement. So to make this work, you must have, it's kind of similar to a file. We have to have a connection to our database to be able to write to it. And in order to establish that, we use this statement here that says connection equals SQLite3.connect some database.db. And what this is in here in quotes is the file name of your database. What do you suppose happens if it doesn't exist? Knowing what, and think about how the files system worked. Yes, so if the database doesn't exist on the file that we specify in here, what do you suppose happens? Actually, no. Remember, with a file, if it doesn't exist, it will create the file for you. Similarly, with a database, if it tries to connect to a database that doesn't exist, it will also say, oh, you must want a database here, so it will create it for you. That's how you create a database or a file in Python is you just connect to it. If it's not there, it'll create it for you. So the next thing you will learn to use after you have a connection is a cursor. The cursor is actually basically this thing that we're going to use to send SQL commands. So some of you may have already had SQL or SQL as a course. There is a course that we have at CNM that you can take to learn SQL. For this, I'm going to kind of give you the queries that you're going to need or help you build them if you need help building them. So we're going to use very simple queries, and we're not going to get in that much detail. The neat thing about this is that if you do take that course, then combining that with your Python knowledge, you'll be able to actually make applications that work with data. So, like a file, also a database, you need to tell it when you want to save stuff. So, with databases, you have a commit statement. And what a commit statement does is, and for efficiency's sake, it doesn't, the database doesn't always push everything in the database file. It sometimes saves up some changes and then flushes them all to the database, and then the database gets updated. So the commit makes sure that everything is done and that your changes have been modified on the database. So you always want to do a commit before you get done working with your database, and then there's a close for the connection. This is very similar to the file close. It's important when you have multiple users on a database, even though you can have multiple users accessing a database at the same time, you also want to make sure you close it because it's not an infinite number of users that can access the database at one time. So just like with a file, you open it, you do your work, and you close it as fast as possible. Does that make sense? So the basic process for working with a database is this: import SQLite3, establish a connection, and here's an example of the connection. Instantiate a cursor. We're going to see later how to use that cursor to do things with the database. Commit your changes and close. So that's the basic template for working with a database. It's a little bit like working with a file, but you have like one additional step here with the cursor, and then you have the commit thing, which is extra. So, SQL query language is a language designed to provide commands to databases. So, in many ways, when you're working with SQL, you are writing code that writes code. It's a little meta, but what SQL provides you the ability to do is CRUD your data. And that acronym stands for create, read, update, or actually it's create, retrieve usually, update, and delete. Those are the basic things we do to a database. And a database really is a collection of tables. And a table is a collection of rows, and rows are a collection of columns of data. So CRUD is the common acronym used to what we do with that. You either create a new row of data in a table, or you read that row of data, or you update it, making changes to it, or you delete that row. Those are kind of all the functions you do with data. So in order to do that, we use the cursor.execute command, and what you pass to the cursor execute command is your SQL command as a string. So we're passing a string to our Python code, which then will send that string to the database, and then the database will read that and do whatever that command tells it to do. So let's create a program to create and initialize a database. So let me type along with you all. And so we're going to start off by importing SQLite3. And then we're going to create a connection. And often so this program we're going to create is actually one just to create the database. And so we're going to use this to create the database. And so it's the kind of thing where you would run it one time and then probably not use it after that, because then you would have the starting database. Unless you modified how you want your database to be structured, then you would run it again. So I'm going to call this demodb.db. And from that connection, we create a cursor. And with that cursor, we're going to execute a command. Now, you could just start typing your command like this, but I'm going to use 3 single quotes. What that allows me to do is write my command on the following lines, and it doesn't care about carriage returns or things like that. So if I have a multi-line thing to type, 3 single quotes before and after my string makes it a lot easier. So I'm going to create a table called table demo, open parentheses, and then we're just going to create some. Num1 field will be a float. Num2 field. Obviously, if you're doing this for real, you would have more meaningful names. So this is a string. The single quotes make it so that we can put it on multiple lines, and we're going to send this string to our database. And we're going to need to have something to write into this table. So we're going to create a list of tuples. Let's put 1.1 since it's a float. And so this creates a table. The next thing we need to do is put that data into this table. So the way this works is here. This create table says create a table. We give it a name that we want for our table. That could be anything you wanted. Table demo, my really cool table. That's your identifier. And then the remaining fields are kind of like variable declarations, but you have to use these keywords instead of the ones you have to give it a type. So we have to say, whatever you want the name of the field, and then either float, int, or text. And where you can find this information on how to write these statements is we can go, there's a W3 Schools is a website that has information on how to write these commands. And if you go to W3 Schools, they even have some Python stuff too here. But we want to learn SQL. So if we scroll down here, we have learn SQL down at the bottom. Yeah, SQL statements for different databases can be slightly different. So generally, the main parts of the syntax are pretty much the same. A lot of things that are different are the names of the types of databases. So you sometimes have to go to Sqlite3 and documentation. And you can find information on some of the key aspects of it. So there's slight differences in databases. But I'm going to do this part of the exercise. Before we get too far along, I'm going to leave this as it is. And I'm going to save this . I'm going to create a new folder called db demo. I'm going to call it 4 because I've done a few of these. I'm going to call this one initdb.py. So this program's job is to initialize my database. Oh, I sent out an announcement, but thanks for letting me know. Let me get that sorted out.
Yeah, so yeah, just
Oh, there's.
okay. So yeah, you're actually going to have to do that since we only have one parameter that the distance function takes in. So you're going to have to pass it into the property using the third instantiation, which would be point3 dot point coordinates equals lat then comma lon.
Okay.
Because we didn't have like inside the distance function, we didn't have like move the lat and lon parameters. We just put in 2 point for the parameters. So I mean, I'm pretty sure that's like a list or something like that, or an array.
So today's meeting will be on WebEx. Actually, from here on out, we're going to be on WebEx, I think, because we usually have problems on the other ones, on this one. So I'll see you all on WebEx.
I guess we'll continue this later then.
Yeah, that's fine.
Okay.
All right, later.
Okay, let's see.
Donuts. Mm-hmm. Nice. What is the story? You're frozen.
Okay, can everyone hear me? So today we're looking at, for those of you who just joined us, we're looking at how to use databases. And we're going to use a framework called SQLite3. SQLite3 is a nice lightweight database. And the way you get it is you import SQLite3 and then what you do is the pattern is really import SQLite3, create a connection with the connection method, create a cursor with connection.cursor, and this is the same as what you made your connection. Then you use the cursor to execute whatever SQL commands, and I'll pretty much give you the formats of the SQL commands you want. This will not be a full-up SQL course. And then you commit your cursor and then you close. So right now what we're using this for is to create a database. And this will create a database called DemoDB. When you connect to a database that isn't there, so you notice that here we don't have a database that exists. This will actually create the database for us. So I'm going to go ahead and save this, and I'm saving it in a directory. Put this code all in one directory because it will be able to make sure that you can find this stuff easily rather than having it milled in with everything else. So once I create this, I'm going to run it. I think I need an equals there. Let's see, how did I misspelled commit? Oh, it's connection.commit. So one thing that happened here is it ran and it actually created my database down here. There was an error, so I'm going to just delete that database and then run this program again, since I had some changes. You might find, if you find that it tells you that it has a connection already open, if you close out your shell window and then rerun it, it will close that connection in case you didn't get to the close. So now what you'll notice is I ran this code and now I have demodb.db sitting here. So this connection didn't find it and it went ahead and created demodb. Did that work for everyone? So I'll give everyone a second to get caught up. What works better, Adam? Is it the sound or is it just the interface? Right on. Yeah, I think this is going to be how I'm going to be doing collaboration from here on out. And besides which, I think we're moving off of Blackboard eventually anyway. Let's see. Operational error, table. Okay. So that's the next part of my demo. Watch. If I have DemoDB already there and I run this again, I get the same error you do. So that means that DemoDB already exists. So here's the thing with when you're working with the initial table create. Often we find we did something wrong. We need to fix it. So we need to delete that database. Notice that when I try to delete this database, it says, you see, this action can't be completed because the file is open in Python. Notice, so I got an error and it stopped before it could get to the close connection. So how do I handle that? So what I do is I just close out the shell here and then I can delete that database. And then I can run this again. And then it recreates the database. So one of the things when you're working and you're troubleshooting your database, you may need to do this is, you get some, oh, I need to change this. and you need to delete the database. If this close connection hasn't gotten to, the connection will still be open, and then you can't close it. So what does that suggest that we should do with our close? Really what we should be doing is probably putting this in a try. Finally. Because then we can make sure that this actually gets closed. And so now if I were to run this, if it already existed, then at least I would know that I can delete that and the close is done. So this is a good approach to use a try finally with your connections and also with your files. That should help you. Does that make sense? Yeah, so if you get stuck and you can't delete a file, just close whatever window is open, and that will close the connection, and then you can rerun it. And it's probably a really good idea to put your connection in a finally. You could even put you could probably even put this in there, and that probably would be a good idea. Okay. So this is all fine and good. It makes a table, but let's say we wanted to initialize some data. So what we could do is in here. So really, what we've done is this: we've create a table, and if you had multiple tables, you would run that. You would have multiples of those commands, and they'd have different names, and you could create multiple tables. Often when you're making a database, yes, I'm recording. Thank you. Often when you're making a database, you might want to initialize the database with data. Not always. A lot of times, you might just be create an empty table, and that's all you want. So let's see what it'd take to insert a row of data. So we could do this: cursor.execute. And right now, we can't really look at this database table. It's kind of hard to look at. So some of this, there are third-party applications you can get to look at your SQLite database. I'm just going to do this with code. So I'm going to make another. By the way, SQLite is not case sensitive for the keywords. I just tend to capitalize them. And the insert command, which if we go to SQL source, there's, let's see, we had create table. Let's see if we can find that. This is the create table command. And if you go to W3 Schools, it'll show you the format of the command. And there's also drop tables and alter table commands and all kinds of things. If you're creating the code just to create a table in the first place, typically you're not going to drop and alter because, well, you might if you're like doing database update code. But the other thing we're going to do is we're going to do a insert command. So the ones that you're primarily going to use are insert, update, delete, and select. So the insert command is basically say insert into table name. You identify the columns that you want, and then you put the values. If you're going to be putting into all the columns, you could just do an insert into the table name, and then you put in the values you want into each column. And so value 1 goes to column 1, value 2 goes in column 2, etc. So let's take a look at our code again. And what we're going to do is we're going to insert into table demo. And I'm going to use the longer form of the code just to and let's say I put 42.32 comma next one's an int. Actually, I'll put 3.14 here. I'll put 42 here and some text. Doesn't really matter. We're going to be getting rid of this soon anyway, just to illustrate how this works. So I'm going to run this. And it creates a DB. Now I'm going to look at this with Notepad++, and just to show you that it's not tremendously readable stuff. You know, it's a bunch of null characters. There's some text, so we can see that's probably, you know, the values, but it's a binary format file, so you can't really read these files. So we have to take on faith until we actually open up the file to read that that the stuff's there. So that would work, but let's say I have a whole bunch of information. So first of all, did that work for everybody? Tell me what kinds of errors you're getting so I can... You may need to delete the existing database and run it again. So before each of these iterations, you know, right-click and delete the existing database. And if it won't delete, close out your shell window, then delete it, and then go back and run it again. Half of this is just knowing how to deal with the operating system closing your files and stuff. Cool. Yeah, probably there. So, okay, so let's say that we had a whole bunch of stuff. Well, we could write, you know, for each line we could write a separate cursor, but I'm going to show you a little easier way. So what's easier is is maybe is defining a list of tuples. And I'm just going to put some dummy data in here. So I'm going to make a list with 3 tuples in it, just to because it's a convenient structure, and then I'm going to for line in data. And I want to put this in here. Now, one way that might be tempting to do this is, hey, I need to take, each, if I think about it, num1 field, I need to put each of these elements. So I could do %s's in here. Oh, actually that stays the same. %s's would actually go here. So we would, perhaps do something like this. And then we would do this. And it's not a big deal with this particular part of the program because, well, but but this is basically string concatenation. Anyone recognize what kind of hazard is created by doing things this way? There's a security vulnerability. And it's not as big a vulnerability here because I'm not asking the user for this information. I'm hard coding it in here. Yes, SQL injection. So if any of you are involved in security, one of the things you want to think about when you're working with databases is something called SQL injection. And usually what it comes down to is what causes it is whenever you concatenate strings together in order to make your SQL code. And where that becomes a problem is if the user is the one that's providing you the information to concatenate in, they can actually insert their own code because they type into your input field what they want, and because this is just a string, that gets inserted where these %s's are, and they can do some neat things in order to actually get to do things to the database which you wouldn't want to do, have them do. And there's this famous comic, XKCD, and it basically says, hi, this is your son's school. We have some computer trouble. Oh dear, did he break something? Anyway, did you really name your son Robert, quote, close parentheses, semicolon, drop table students, semicolon, dash, dash? Oh yes, little Bobby Tables we call him. Well, we've lost this year's student records. I hope you're happy. I hope you've learned, and then she says, I hope you've learned to sanitize your database inputs. And basically what it is when the person typed into, an input field like your GUI, what this does is they terminated the previous command by putting in a name, a colon, and a parentheses, and a semicolon, which finishes the previous SQL command, and then they inserted their own SQL command, which is drop table students, semicolon, which would actually drop the table, and then they put a dash dash to comment out everything else that happens in that string that gets concatenated. So how do you deal with that? Well, if you look up SQLite3 SQL injection, Python maybe even. Let's see. There will be, this one might have it. This is Stack Overflow. There's probably better sites. Let's see. There's actually a website that has reference. What you want to use instead of your %s is you want to use, for SQLite 3, let's see, it's a question mark. And let me see if I can find the reference. For let's see. Yeah, this is it. This website has a bunch of stuff on preventing SQL injection based on your language, and with Python, it says here, if you're using SQLite 3, use a question mark. And so that means that really the way we should be doing this is using question marks here. And the question marks are actually pretty nice. So you do it like this, and then you put a comma, and then you put your tuple here. So this cursor execute command, you take in a command, you put question marks where you need to fill in parameters, and then you put your parameters as a sequence object. Actually, in this case, because that's already a tuple, I can just put data here, and it will take each element of the data and put it into each question mark, and will build it for us. Yeah, in C# we use parameterized queries, very similar. The question marks are basically placeholders, and the execute command will actually sanitize the inputs from this list. And actually, I'm sorry, this should be lined. So I should be grabbing that. Actually, I think I'm going to call this row. It's better. So we're going to go for each row in our data, and then maybe actually this would be better thought of as table. So for each row in table, we're going to take the row and insert it as a row into table demo. And the question marks basically, this is a placeholder for 1.1. This is a placeholder for 11. This is a placeholder for line 1 text. And you can see that means that 1.1 will go into num field, 11 will go to num2 field, and line 1 text will go into string field. Does that make sense? So that's the proper way to use parameters in Python. Use question marks, not %s for SQLite3. You got to look up whichever database you're using. You have to look up how to structure this command, because realize you're just building a text string which cursor is just going to send to the database, and the database will then take that and execute that. So every database might have some slight differences. They're not as big onto standardization apparently in the database world as we are in programming. So I'm going to go ahead and run this. It creates my database, and at this point I don't know what whether I've read it or not. So in order to I'm going to take a 10-minute break. We'll reconvene at 2:30, and then that'll give everyone a chance to get caught up with this part. And then the next step is we're going to open up that database and read from it and see the data in it. So we'll do a break until 2:30. Can everyone hear me? Okay, so now what we want to do is we want to be able to read this file. So we're going to create a new file. So that init program is really meant to just create the database. But we're going to do very similar things with this. For one thing, we're going to import SQLite. And so I'm actually going to kind of take most of this. In fact, I will take all of this to start off my new program. And what I'm going to get rid of is this cursor.execute, this initialize table, so I just have the starting parts of this program. So SQLite3, got my connection, got my cursor, got my finally, and then I'm going to save this as dbapp.py. So there's dbapp.py. And I'm going to put my SQL command in a separate variable just to kind of make it a little bit simpler. And it's going to be, and it's useful kind of to look at the other program so I know the name of my table. I'm going to say select star, which means everything, from TBL demo. So that's my SQL command. And then what I'm going to do is cursor.execute my SQL command. And then I'm going to say results is equal to cursor.fetchAll. And then I'm going to print results. So what this is my SQL command. Basically, that's my SQL code. If I go look up from W3 Schools, I can look up the select command, and it's a select, and then you list your columns from table name. If you say select for asterisk from table name, it'll grab all of the columns from that table. So that's how I developed that. And I could have put this directly into this execute. I just find it easier to put it in a variable sometimes and pass a variable to the execute. And then I'm calling this fetch all command. What this fetch all command does is once this gets executed, the cursor is holding all the data that it got back from that database. So at that point, we need to do is get it out of the cursor and put it into something. So we're going to get whatever we got out of there with this fetch all and put it in results, and then we're going to see what results looks like. So I'm going to run this function. I'm going to save its changes, and let's see. Oh, writing in the wrong version of Python. And what did it get from the, what did this code get from our database? Yeah, and what type of thing is that, looking at the first and last characters of these things? It's a list. If you've got an empty list, odds are your initialization code didn't actually run. If that's the case, delete your demo.db, run your initialization code again, check your initialization code, make sure that it's structured properly, that it's got a table, it's iterating through every element of that table, and it's writing that row. Rerun it to get your DB, and then rerun your program and see if you get it. Yeah, so you got a list of rows, and each row is represented by a tuple. And within the tuple, you have 3 elements. So if I wanted to get the second row, what would I put here? Yep. So if I index out the results, I can get each individual row. If I put 0, I should get the first one. If I put 2, I should get the last one. Does that make sense? Now let's say I wanted this 33. How would I get the 33? Yes, so realize this gets me a tuple. To get the element of tuple, I just add the next index to get to index within that tuple. So this structure that they give you is actually very versatile. It's just a list. You already know how to index, so you can get anything you want out of that. So I'm going to, let's say we want to display this nicely. So I'm going to do a for loop. I'm going to say for line in results. And for now, I'll just say print line. And I can see I can get each line in a nice tuple. And then if I wanted to display that, I could just say, I could maybe create a format. Is equal to %10f, comma, %10s, %10s. That means use 10 characters and %10s. That'll be my format. Actually, I'm just going to put spaces between these. And then I could say print format str %line. And well, actually, everything's right justified. If I want it to be left justified, I can make my, and maybe I don't want those extra spaces. And this isn't going to be very big, so maybe this will be 6, and then the second line, I'll make that 6, and then I'll leave that as maybe more like 15. That looks like a better table. And I could then use that same format string up here, and I could put the headers in here. So what I'm going to do here is I'm just going to use that format string to both for the headers and also for the actual data. And when I run that, I get everything in a nice table. Does that make sense? So we'll stop there, and next time we'll delve into using a database some more. Just to review, really this is the database part right here. Create a connection, create a cursor, send an SQL command, look the SQL commands up on W3Schools, and then write your command, execute your command. If you have anything coming back from the command, you can do a cursor.fetchAll to get the results out. The results will be in the format of a list of tuples. Knowing that, then you can do what you want to do. In this case, what we decided to do was create a format string and display a header, and then iterate through each tuple in this list, pass it to our format string to take each element and throw it into the format to display the results. Are there any questions? Okay, the rest is lab time. Let me know if you need any help on your existing programs. And next time we're going to go through this more, and we're going to not only retrieve, but we're going to insert, update, and delete as well. Thank you. If you want to help each other, that works with me. If you get stuck, then let me know. Oh, let me take a look at that. I may have to dig through that a little bit.